Pre-AP Calculus, we're still in Note 7.5, second video. So we had learned some translating and reflection rules for different types of functions. Let's review those real quick. One, let's say that we multiplied the outside of the function by negative. That's going to be a vertical reflection. As far as coordinate rules go, that's going to change the sign of the y values. Well, what happens if we multiply the inside of the function by negative? It's going to be a horizontal reflection. And the x values are going to change signs. What happens if we add a number to the outside of a function, like a k? That's going to be a vertical translation. And we are going to take the y values and they're going to increase or decrease by whatever k is. If we add or subtract a number from the inside of the function, that is a horizontal translation. And the x values are going to increase or decrease. It's all review. Hopefully you're like, why are you telling me this for the 9,000th time? It's important, that's why. These shifting rules can be applied to exponential functions as well. So let's check out this compared to the parent 2 to the x. Please remember, super important, that this 2 is being raised to an x plus 3. This negative is an afterthought. If it helps, put the 2 in parentheses. If we meant for the negative to be a part of the base, it would be like this. But that is not the case. So this is a 2 that's being raised to the x plus 3. We want our base to be bigger than 1. Check. We want the coefficient of x to be 1. Also check. So how is this going to differ from the parent? Well, this negative is going to cause a vertical reflection. That's because a is less than 0. And graphically, that means the graph will be below the horizontal asymptote. And the other thing, we're going to be translating to the left 3 and up 2. Nothing else differs between this and the parent graph. If you knew the basic points of the basic function f of x equals 2 to the x, how could you get points for the new graph? This is asking for the coordinate rule. So let's say that f of x is the original function, which it is, and let's say that we want to transform this to get to g of x, our new function right up here. We're going to take the original ordered pairs, and using what we've just set up here, vertically, we are going to reflect, so we're multiplying by a negative, and then we're going to translate it up 2. So as far as the y value goes, we're going to change the signs, and then we're going to add 2. As far as the x value goes, we're just translating left 3, so every x value, we subtract 3 from it. This is the coordinate rule. If you took any point on the original graph, and you changed the x values by subtracting 3, and you took the appropriate y value and you change the sign and add 2, you would get a new point on this graph. C, graph the function. And it's I'm giving you these steps here in red. These steps will not be given to you on a test or in your homework. These are things that you have to know. And I believe this is the easiest, most efficient way to do this. 1, find the location of the asymptote giving justification. G of x has a constant of 2. Therefore, g of x has a horizontal asymptote at y equals 2. Let's graph that little fella. There's my horizontal asymptote, dashed horizontal line. 2, state the graph is above or below the horizontal asymptote giving justification. A is less than 0. Therefore, g of x is below the horizontal asymptote. So I'm just going to take a moment. I'm going to go to my graph, and I'm just going to write the word below. And I'm going to write it below the horizontal asymptote, so I make sure that my graph is below it. 3, identify if the graph is growing towards or away from the horizontal asymptote. C, in this case, that's what you're multiplying by x, is 1, so it's bigger than 0. So that's just like the parent, and just like the parent, g of x is growing away from the horizontal asymptote. I'm using this word growing poorly. I don't mean growing as in growth. I'll tell you what, let me not use the word growing. Let's say is going. Yeah, I want to say going towards or away, because I don't want to confuse this with growth or decay, because that's not what I'm talking about. So if it's going away from the horizontal asymptote, I'm just going to write over here on the right, this is supposed to be growing. Actually, I'll just put it up here by. Supposed to be growing away from the horizontal asymptote as you go to the right. So right now, we should know the general shape of this is going to be like this. We just got to figure out where that curve is going to go. 4, use the coordinate rule to find the new location of 0, 1. Well, my coordinate rule is this right here. So if I take 0, 1, I'm supposed to subtract 3 from 0. So it's going to be negative 3. Supposed to change the sign of 1, negative 1, and then add 2 to it. I'm going to get positive 1. 2 to it. Sound like I said 2. Put that point on my graph. Negative 3, positive 1 is right here. 5, there's no work to show for this here on the side. Use the base to find other points. The base is 2. So as I move to the right or the left one, I should be doubling my y value. Since I'm going away from the horizontal asymptote, as I go to the right one, I'm going to double the space. So it was 1, now it's going to be a 2. I go from my magic point here, using that term loosely. It's not a mathematical term. If I go to the right 2, I double my space. Instead of 2, I'm going to go 4. Not too far. So I was, from my starting point, I went down 1, then 2, then 4, then I'm going to go down 8. And then I would go down 16. There's no space for that. As I go back this way, my distance gets cut in half every time I go to the left one. Connect my points. And that is my graph. Identify the domain and range. Well, the domain is the same every time it's an exponential function. It's all real numbers. The range is either everything, all the numbers above the horizontal asymptote or all numbers below the horizontal asymptote. Our graph is below. So that's my range. All right, that is the gist of how we're going to do this. I'm going to stop this video and then we'll do 3 or 4 more examples of this.